Dear students, in the last class, we discussed about law of conservation of momentum. What we discussed? We discussed law of conservation of momentum. So we know that if there is no external force acting on the system, or if there is no external force acting on the body, the momentum is conserved. Momentum is conserved. Momentum is conserved, which means initial momentum is equal to final momentum. Initial momentum is equal to final momentum. Based on this topic, so foundation point of view, whether you are a techno student or a Olympiad student, or you are writing some any examinations, right? So based on this, many questions you can ask. See, now we will see based on conservation of momentum how the questions will come. See here, for example, here application of conservation of momentum. Application of conservation of momentum. Many applications are there, but we'll try to understand 2-3 applications and the 2 important applications. See, first one. First application, here a gun is given. A gun is given, right? Gun is there. Of mass capital M. Gun mass is how much? Capital M. So initially we know I'm having gun and inside bullet is there, right? Not a bullet, right? It is small bullet will be there, that one. Correct? Inside the gun, bullet is there. Now what I did? I triggered. When I triggered, bullet will come out. Bullet will come out. So when bullet is coming out, what will observe? When bullet is coming out, this gun will give backward jerk. Correct? When I triggered, when bullet is coming out, it will give backward jerk. I hope you understood, right? So that one is called recoil velocity. Which velocity it is? Recoil velocity. So we'll try to understand here. Now initially gun is there, and initially bullet is also there here. Bullet is there. And when I triggered, this bullet is there, na? This bullet. And this mass of bullet is small m. Mass of bullet is small m. And this one is coming out with some velocity, for example, u. Velocity u. So I already told you, when we triggered, when the bullet is coming out, the gun will move backward jerk. Gun will move, or this gun will move backward with some velocity. That velocity is called recoil velocity. So here, when the bullet is coming out, this gun will move the backward jerk, or gun will move backward with some velocity. That velocity is called recoil velocity. So he will ask, with what velocity gun will move backward? With what velocity gun will move backward? Try to understand here. In this situation, initially bullet is inside the gun. When we triggered, and again a bullet is coming out, there is no external force acting on the gun, or there is no external force on the system. So here, if there is no external force acting on the system or on the body, the momentum is conserved. Momentum is conserved, which means initial momentum is equal to final momentum. Initial momentum is equal to final momentum. So now here I will write initial momentum. Initial is equal to final momentum. So we know momentum is the product of mass and velocity. Momentum is product of mass and velocity, MV formula, right? So initially, if you see, both gun and bullet which are at rest, both gun and bullet which are at rest. So if a particle or if a gun is at rest, so what is its momentum? Momentum is 0. Momentum of gun is 0 plus initial momentum of bullet is also 0. Initial momentum of bullet is also 0. Now you tell me, final, when it is triggered, bullet will move forward. Bullet will move forward, it's a velocity u. When it is move forward, it's a velocity u, it is having some momentum. So momentum is mass into velocity. So I will write m into u. When bullet is coming outward, gun will move backward. So both directions are opposite. Bullet, gun, both are in opposite direction. So if I am considering this is positive x-axis, it should be negative. So I will write minus m with what velocity gun is moving? V velocity v. So I got here mu minus mv is equal to 0. So mu is equal to mv. So important formula. From that, if he is asking the velocity of gun, so velocity of gun can be written as mu by this mv capital M. So capital M. So in this way, we can able to find out the recoil velocity of the gun. With what velocity the gun is moving backward. Clear? I hope you understood, right? See, based on this one numerical, we'll try to understand. Make a note. See here, I am saying that gun is there of mass, for example, 1 kg. Of mass is how much? 1 kg. And when I triggered, bullet is coming out. Mass is, for example, I will write 0.1 kg. 0.1 kg. So this bullet is coming outward with some velocity, for example, 200 meter per second. 200 meter per second. He is asking that find the recoil velocity of gun. Find the recoil velocity of gun. Clear? Now see, no need to remember the formula. See here, we know that as there is no external force, momentum is conserved. So initial momentum is equal to final momentum. See, initial momentum, I know initially both bullet and gun which are at rest. So initial momentum is 0 for the gun and 0 for the bullet. This is what we discussed, right? Which is equal to final momentum. Mass of bullet and the velocity of bullet. How much mass of bullet? Mass of bullet and velocity of bullet minus mass of gun, velocity of gun. We know already. Why? Because why I wrote minus here? Bullet is moving forward and gun is moving backward. Both are opposite directions. That's why I wrote here minus. So I will write 0 is equal to, what is mass of gun? Mass of gun is 0.1 into u. Velocity of bullet, how much it is? 200. Minus mass of gun, how much it is? 1 kg into v, I want to calculate. Clear? Now I will write here, we can write this one as 0.1 can be written as 1 by 10. So I will write 0 is equal to 1 by 10 into 200 minus v. So 1 0 1 0 get cancelled. So 0 is equal to 20 minus v. So v is equal to 20 meter per second. So this will be the answer. Clear? The first and important application for your classes. For foundation level, 8th, 9th, 10th, the first important topic. Clear? Based on conservation of momentum. This one we are saying it as recoil velocity of gun. Recoil velocity of gun. I hope you understood, right? Numerical understood, right? So we will go with the next application. So in other way, how we will ask the questions, right? See. See here, in second application, for example here, I am saying that one sandbag is there. Sandbag. Sandbag is simply hanging, like we know boxing bag, right? Boxing, right? Sandbag is there, right? Now I'm saying that one bullet is there. Sandbag, I will write mass capital M. Sandbag mass is how much capital M? This bullet mass is small m and moving with velocity, for example u. Initially this bullet is moving with velocity and sandbag is at rest. Initially it is at rest. Correct? Now you tell me, this is sandbag. Sandbag is suspended. So bullet is coming, and when it hits, it sticks. It entered into the sandbag. When it is entered into the sandbag, with the sandbag the body is moving. Correct? Am I trying to understand? When it is entered and it is stuck into the sandbag, when it is stuck into the sandbag, when I will kick, so it is moving, right? In the similar manner, when bullet will hit, so along with the bullet, the whole sandbag will move. Along with the bullet, the whole sandbag will move. So in this situation, when bullet is entered like this, for example, the whole system will move in this direction with some velocity v. With some velocity v. He will ask that find the final velocity. Find the final velocity. Try to understand here. Again the same situation. Here. I will write initial momentum is equal to final momentum. So initial momentum. So in the last case, both gun and bullet which are at rest. So initial momentum for both gun and bullet is 0. But if you observe, this one is at rest and this one is moving. Correct? So if you see the initial momentum of the bullet is mu plus initial momentum of the sandbag. Initial momentum of the sandbag is 0, which is equal to, now you tell me, here sandbag is there. When bullet is stuck into the sandbag, both are moving. When both are moving, both sandbag and bullet are having the same velocities. So here, after if you see the final momentum, so mass of the bullet into velocity plus mass of sandbag into velocity. I hope you understood, right? Why? Because both are stick with each other and moving together. When both are stick with each other and moving together, both velocities should remain same. That's why I wrote here v and here it is v. Clear? Now see here, mu is equal to, here I will write here v is there, here v is there. So I will take v is common. So when v is common, so m plus m. So v is equal to mu by m plus m. This will be the answer. In some questions, theoretical questions he will ask. If theoretical questions he will ask, this will be the answer. If numerical point of view is asking, we will substitute and we will find. Clear? I hope you understood, right? So based on this one also, we will try to do one numerical. Now see here, question will be like this. Here sandbag is there. Of mass, for example, 100 kg. Sandbag of mass 100 kg. So again, bullet of mass 0.1 kg. Moving with velocity 200 meter per second. Bullet of how much? Mass 0.1 kg. Moving with velocity 200 meter per second. And it is stuck here. After entering into the sandbag, then the whole system is moving in this direction with some velocity v. So he is asking that after stuck into sandbag, find the velocity of bullet and sandbag. He don't know. That's why he asked that find the velocity of bullet and sandbag. But we know after stuck, both will move with the same velocity. So velocity of bullet is equal to velocity of sandbag. Clear? Now see here. Initial momentum. Tell me, what is initial momentum? Mass into velocity. This one is at rest. So initial momentum is 0. But it is moving. So it is having some initial momentum. Initial momentum. What is initial momentum here? Mass into velocity, which is equal to, after hitting, both are moving. So mass into velocity plus mass into velocity. Mass into velocity plus mass into velocity. So here I will write m can be written as 0.1 into u. U is how much? 200, which is equal to m can be written as 0.1. And again v I have to calculate, plus what is m here? M is 100. 100 into v. Clear? So here we will get 0.1 can be written as 1 by 10 into 200, which is equal to 1 by 10 into v plus 100 into v. Clear? Now here we can write this one will cancel. So I will write here. So here 20 is remaining. 20 is remaining, which is equal to, here v I will take common. So if I will take common v in brackets, 1 by 10 plus 100 will be there. 1 by 10 plus 100. Now we know how to do LCM, right? I will write directly. Otherwise you do LCM and find out. You will get the same answer. So 20 is equal to v into 1 plus 1000 will come by 100. So by 10. The denominator 10 is there now, the 10 will come here. So here you will get 20 is equal to v into 1001 by 10. So finally we can write v is equal to 10 will go this side. So 200 by 1001 meter per second. This will be the answer. Clear? I hope you are understanding, right? So calculations, it may be difficult, but if you will sit and solve line by line, you will get the answer. But concept is very, very important. Clear? Now we will see one more application, how we can ask the questions. In other way, how we can ask the questions. For example, here third application I can write here a car is there. Car A moving with velocity. For example, I will just we are considering the toy cars, right? Toy car. This mass I will write for example 10 kg. Mass 10 kg, and it is moving with the velocity of, for example, 20 meter per second. 20 meter per second. So again, for example, here one more car is there. Correct? And it is moving with velocity, for example, 10 meter per second. And this mass I will write, it is 5 kg. Mass I will write 5 kg. Try to understand. It is moving with 10 and it is moving with 20 on the same line. Then what will happen? Absolutely, they will collide. They will hit with each other, right? So here hitting takes place. Right? Then after hitting, so here we will see A moving with 15 meter per second. A moving with 15 meter per second. And he will ask B velocity how much? B velocity how much? Question is clear? Both are moving, and here collision takes place. It will hit. After hitting, this velocity, A velocity is 15 and B velocity we have to calculate, right? See here, what we are going to calculate? We are going to calculate the final velocity of car B. Car B velocity we have to calculate, right? Again here, there is no external force. If there is no external force, Tell me, if there is no external force, momentum will be conserved. Momentum will be conserved means initial momentum is equal to final momentum. I will apply like this only. Initial momentum. Here it is also moving, this one is also moving. So both are having some initial momentums, right? So initial momentum I will write here mass into velocity plus this mass into velocity, which is equal to final momentum. After hitting now, this will be final momentum. What is final momentum here? Mass of here remains same, 10. Velocity becomes 15 plus what is the mass of B? Mass of B is 5 kg and velocity is how much? 10. So velocity we have to calculate, right? Mass of B is 5 kg and velocity of B we have to calculate. So again, this one is mathematical expression. We can solve this one easily. So I will write 10 into 20, 200 plus 5 into 10, 50, which is equal to 10 into 15, 150 plus 5V. So here I will write it is 250, which is equal to 150 plus 5V. So 150, it will come here. So 150 will come here means 250 minus 150, which is equal to 5V. So here it will be 100. 100 is equal to 5V. So V is equal to 100 by 5, which is equal to 20 meter per second. This will be the answer. Clear? So any question, try to understand whether any external force is there or not. External force is there or not. If there is no external force, we know that according to the conservation of momentum, initial momentum is equal to final momentum. Clear? I hope you understood, right? Thank you.